Hello, Stats 300 class, and this is Professor Gonzalez. And this is our first homework problem set that I'm going to go over. We are looking at homework from the assignment side of ALEKS 1.1. And in this particular section, there's some vocabulary that I'd like to go over. But let's start off with our homework here. It says determine whether the number described as a statistic or a parameter. Now, one thing that you might want to know is, let me get some color here, and let's go ahead and just underline this and take a note. A statistic is a number that describes a sample. That describes a sample. Now, on the other hand, a parameter is a number that describes a population. Okay, so when you have that kind of helps us with the question. It says the average ACT score of all testers from a local high school is 23. Now they're looking for all, let me underline that, they're looking for all the testers from a local high school. And this could be, I mean, sometimes you could second guess some of this stuff. But they're looking for all the testers from a local high school, and this means that the high school is the population. So they're looking for that. They're telling us the average ACT score of all testers from a local high school. So because it's from the total population, this is going to be a parameter. Now, if they said something like they were sampling some testers from a local high school, well, then I would say that is a statistic because it's a number that describes a sample. But they want all testers from a local high school, so that's a parameter of the population at the high school. Okay, let's go on to question number 2. Now, before we do too much of question number 2, let me do a little more defining. But I think we're going to have to do some notes on some of this stuff. This first thing, it says identify the kind of sample. Now, I think we better define what a sample is. A sample is a subset of a population. You know, if I was going to make a graphic of something like this, we might do something like, let's see, so we say green, let's say this is a population. Okay. So a sample is a subset of a population. Well, let's say this green is a population. Well, the sample would be this little part, a subset, so that'd be a sample. Now, there's a lot to samples. The reason why we take a sample is because the population is probably going to be something that's too large for us to calculate or ask or talk to or interview or survey. So taking a subset of that called a sample is going to be the next best thing. And then we look at the sample, right? We look at the sample, which is, once again, a statistic, right? Statistics, a number that describes the sample. So then we try to make statistics about the sample, and it doesn't really do us much good unless that sample represents the population. So that means when we take this sample, it's really important that sample represents the population. Otherwise, what we say about the sample doesn't tell us about the population, and that's usually what our goal is. So, so this makes sampling really important. You could imagine if I happen to ask a question like, how many people use, let's say, Twitter, or how many, how many people use TikTok, right? How many people use TikTok? Well, what if I decided to sample the retirement community, and maybe no one uses TikTok, so my statistics would talk about that TikTok is not a very popular app. However, the problem is I sampled a bunch of old people who don't know what TikTok is. So your sampling is really, really important. So this next set of questions, really 2 through 7, talk about different sampling techniques. So before I do that, I think I need to just kind of do a little lecture about sampling techniques. And some of these are actually, they're pretty easy, but then some of them, like clustering and stratified, can really get confusing between the two. And so I'm going to try to help break that down. Okay, so let me go over here, change my pencil to something else. Let's go down here to some terminology. Now, statistics is the study of procedures for collecting, describing, and drawing conclusions of information. That's statistics. But remember, the other thing that I said was, what's going on here? The other thing I said was a statistic is a number, right? A statistic is a number that describes a sample, but statistics is the process of working with those numbers, okay? A population is the entire collection of individuals about which information is sought out for. So that's the full population. And a sample is a subset of the population containing the individuals that are actually observed. Okay, so we already did that. That basically covers problem number 1. But then that kind of moves us into this part that says a simple random sample. So when we get to sampling, like I said before, it is important to have rules on how you sample, so you make sure, or do the best you can to make sure that your sample represents the population. So a simple random sample, there's my pencil or pen, simple random sample, also, many books or people will just call it SRS for simple random sample of size n, is a sample chosen by a method in which each collection of n population items is equally likely to make up the sample. Now, that's a lot of words there, but really, if you think about a simple random sample, and that's actually, simple random sample is sort of the best way to get a sample, because when you do a simple random sample, each person in the population, or each object in the population, is equally likely to be chosen. So really, a simple random sample is a lot like a lottery, right? Suppose that 10,000 lottery tickets are sold and 5 are drawn as the winning ticket. Each collection of 5 tickets that can be formed is equally likely. So a simple random sample is like a lottery where, or another way to do it is, if I was going to do a simple random sample and I was trying to select, let's say, 50 Sacramento City College students, and it was going to be a simple random sample, I would go to the admissions and records and I would get a roster of all the college students. I'd put a number next to their name and maybe use a random number generator on a computer to randomly select it. Or if the population that I was working with was smaller, maybe I would put everybody's, so if I was going to do a simple random sample of everybody in the class, maybe I'd have everybody put their name on a piece of paper in the class, put the names in a hat, and then we shake the hat and shake the names up, and then randomly pull out 5 names. Well, each person in the class, everybody in the class had an equal chance at being selected. I mean, you have to make sure that the little card that you draw on is the same size and all that, but you get the idea. So that's a simple random sample, and when you're trying to identify if a study is if a simple random sample was used, some of the classic things that you're going to hear is that there was a random number generator, or the people were randomly selected. And when you hear that, it's classically a simple random sample. Okay, let's move on to, let's see. Okay, this is just an example of it. Let's say a physical education professor wants to study the physical fitness level of 2,000 students enrolled at her university. She obtains a list of 20,000 students, numbers them 1 through 20,000, and uses a computer random number generator to generate 100 random integers. So 100 random numbers between 1 and 20,000, then invites 100 students corresponding to those numbers. So basically just put 20,000 names in a hat, shook it up virtually with a computer, and then had the computer pull 100 students. So this is a simple random sample because everybody was equally likely to be chosen. What about this example? The professor in this last example now wants to draw a sample of 50 students to fill out a questionnaire about which sports they play. The professor's 10 o'clock class has 50 students, so she figures, well, this will be easy enough. Let me just take 20 minutes of the class time and have the students fill out a questionnaire. Is this a simple random sample of the university? And the answer is no, because the simple random sample is like a lottery in which each student is in the population has an equal chance, and not everybody in the university had an equal chance to fill this survey out because she just took the easy way out and had 50 students in her 10 o'clock class fill out the survey. So no one else in the college had a chance to fill it out, so this is not a simple random sample. Okay, we have something called samples of convenience. In some cases, it's difficult or impossible to draw a sample in a true random way. In these cases, it's best for us to try something else like some type of convenient method. A sample of convenience is a sample that is not drawn by a well-defined random variable. All right, let's kind of get into some of these samples of convenience. Here's one that let's just talk about this one in particular, and then we'll talk about ways to tweak the simple random sample. A construction engineer has just received a shipment of 1,000 concrete blocks. The blocks have been delivered in a large pile. Usually these things are delivered on pallets, right? The engineer wishes to investigate the crushing strength of the blocks by measuring the strengths in a sample of 10 blocks. So essentially, and this kind of thing does happen, especially when like Caltrans is working on a bridge or something like that. They're very scientific about it, especially when they're in earthquake country. But so you've got these concrete blocks that are delivered, and they want to make sure, the manufacturer says that the crushing strength of these blocks is whatever, and the engineer wants to make sure that that is true, that the manufacturing made these blocks have the strength that they claim that they have. So they want to check these blocks with a sample. Now the best thing to do is to number each block and then randomly choose those numbers out and then get the corresponding blocks. Then it would be a simple random sample. But you could imagine concrete blocks are extremely heavy. If they're piled up high, you'd have to move a bunch of blocks to get to the bottom blocks and stuff like that. So in this example, to draw a simple random sample would require moving blocks from the center to the bottom. And so a sample of convenience would be a simple way to take 10 blocks off the top of the pile. Now this is definitely not a simple random sample, and there can be some real problems with this. The problem with samples of convenience is that they may differ systematically in some way from the population. So let's say that the machine that's making these blocks or the mixture of concrete was not mixed well, and the blocks were super strong, and then somewhere along the way, like let's say, 10 or 15 blocks were made with this mixture of concrete that was not mixed well, and so these blocks are very weak. And so these blocks could be hidden down at the bottom, and so you kind of want to know that with a random sample to see if there's anything out there. And by just grabbing blocks off the top, it can really be misleading. Okay. All right. Let's talk about, so I would say stratified random sample, and another one that we're going to look at is called cluster or a cluster of random sample. Those two you really need to highlight because they're very easy to confuse with each other. So I'm going to talk about them. I'm going to talk about them a little more, and then at the end I'm going to give another example on top of that because I really think that stratified and cluster sampling is, like I said, is very easy to mix up. Okay. In a stratified random sample, the population is divided up into groups called strata. Or stratum. Groups called strata. Oh, strata is plural. Stratum is singular. Okay, so called stratum or strata. Then a simple random sample is drawn from each stratum. So let's see if I can kind of draw some of this out a little bit. And there's a couple. Well, let me finish this definition. Stratified sampling is useful when the strata differs from one another, but the individuals within a stratum tend to be alike. So let me get a little bit of an example going here. So let's say that you wanted to do a random sampling of a high school, let's say. One thing that you can do with that high school is you could break them up into a stratum or to strata. In this case, I'm just going to do a simple breaking of that, a grouping. Now, something that will kind of a hallmark of stratified is that when you break the groups up, there's going to be some characteristic that breaks the groups up. Okay, so in this case, I'm going to say, okay, this high school has 1,000 kids at it, and I'm going to break it up by boys and by girls. And let's say there's 1,000 students, so there's going to be, let's say there's only 300 boys and there's 700 girls. So notice we've taken the population and we stratified them, or we've broken up into strata, broken up into groups. And we had some sort of criteria that broke them up. Another thing that is classic with the stratified sampling is that these groups are different. They're different by whatever we use to break them up. Like, for instance, we wanted to break them up by gender. Oh, and now my pencil's not working. Wanted to break them up by gender. And so that gender was a criteria that you grouped them with. And because you did that, now these groups are very different from each other. Boys are different than girls. And then within the groups, there's that very similarity. Everybody in this group are boys and everybody in this group are girls. So that's a kind of a characteristic of stratified. Now, once you did this, okay, so let's see, so they're called strata. Then, once you've broken them up into their strata, then a simple random sample is drawn from each stratum. So that means that, and the nice thing with this is we can say, okay, now we want a simple random sample, and we're going to draw, let's say 30 boys is our sample going to be. We're going to randomly sample 30 boys out of the boy group, strata, and then we're going to randomly sample 70, and then simple random sample of 70 girls out of the girl group. And so you can see, what if we just did a simple random sample? Well, the danger of that could be, you actually could, if I was going to sample, let's see, I've got 30 and 70. What if I wanted to sample 100 students? What if all 100 randomly came from the boys' side? Then that sample would not represent the population very well at all, because there are more girls than guys, and just by random bad luck, I end up randomly getting all guys. So this stratified system will ensure that I sample 30 guys, and then there's a lot more girls. In fact, there's the ratio is 3 to 7. So then I kind of keep that with my sample, 70 girls, and so that's a really good way to do that. Okay, let's take a look at another type of. Well, okay, they've got a model here, so let's do this. Actually, it's a very similar thing. Company has 800 full-time and 200 part-time employees. To draw a sample of 100 employees, a simple random sample of 80 full-time employees is selected, and a simple random sample of 20 part-time employees is selected. So we've got this these employees that are broken down into two groups. Now, once they group it, it's going to be a stratified or it's going to be clustering, which we haven't talked about yet. But in this case, it's going to be stratified because the groups are classified. There's some characteristic that's classifying these people. And what's the classification over here? Well, the classification is that these guys are full-time. Group 1 is full-time employees, and that's how that group was made. And then this group 2, is classified as part-time employees, and so our characteristic was their employment designation. Are they full-time or are they part-time? So now we've made strata. We have two groups, and then now what's the hallmark of a stratified sample is that now once you've grouped these into two different types of groups, now you're going to do a simple random sample, in this case of 80. So you're going to do a simple random sample of 80 full-timers, and then you're going to do a simple random sample of 20 part-timers to get a stratified random sample of 100 employees. Okay, so that's an example of stratified. So then we go right to cluster sampling, which cluster sampling always gets confused with stratified, and it is very easy to confuse them. Let me just read the definition. It says, in cluster sampling, items are drawn from the population in groups or clusters. Okay, so once again, we get that word groups, and we were just talking about groups in stratified. So there's the confusion right there. Items are drawn from the population in groups or clusters. Cluster sampling is useful when the population is too large and spread out for a simple random sample to be feasible. Wow, they didn't give much there, so I'm gonna add to that a little bit, quite a bit more. Let me do this. Let me do a little example right here, and let's say that Taco Bell they want to do a Taco Bell employee survey. So I want to do a Taco Bell employee survey of all the Taco Bells in California, let's say. Well, if we did a simple random sample of that, we would have to go around to each Taco Bell, get their list of employees, and then make a random number generator and then randomly select it. That might be too hard to do. Well, if it was how about all the Taco Bells in the world? So now we're really talking about something difficult. So another way to do this is by clustering. So let's say, I'm not going to draw circles of all the Taco Bells in the world. That'd take me too long. But let's just say that there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 Taco Bells. Okay, and so this is store number 1, 2, 3, store number 4, 5, 6, 7, 8, 9, 10, 11, and store number 12. So something that's kind of interesting about clustering is that usually the groups are already kind of naturally divided, and so you can see these people, these employees, they're already naturally divided into their own stores. So there's already this grouping cluster that's happening. And for clustering really to work is that notice each of these groups are not homogeneous. Like in stratified, each group, there were boys, there were girls. Each group had had a characteristic that separated them out, and it made the groups different. Whereas in clustering, you've got these groups that have variety in them, right? You go to a Taco Bell and there's going to be men and women or boy and girl employees, right? There's going to be all these different types of employees, so there's going to be a lot of variety. And that's kind of one of the hallmarks of clustering. Another piece is that now what we're going to do is that we're going to randomly or do a simple random selection, and we're going to select one or more clusters, and then everybody in that cluster gets sampled. So the difference here is, let me get a red pen, and then now, wait, well, let me just highlight back over here with the stratified. Stratified, we had groupings, right? So in this last example, we had full-time employees and part-time employees. And then we did a simple random sample within the group. We didn't use everybody in that group. We used a simple random sample in group 1, and then we did a simple random sample in group 2. Clustering, the difference is that we're looking at all of these clusters, and then we're going to do a simple random sample. Let's say I want to randomly sample 3. So I get 12 store numbers, and then I pull 3 numbers out of the hat, and oh, I pulled store number 10, I pulled store number 5, and I pulled store number 3. So now we take each one of those stores, what did I get, 10, 5, and 3, and then all employees of the selected stores are sampled, are surveyed, let's say. Okay, so that's the difference. I'll put some notes on that again because those two just always get confused. Let's go on to the next one. Not as difficult as something called systematic sampling. Actually, this is much easier. In systematic sampling, items are ordered, and then every kth item is chosen to be included in the sample. Systematic sampling is sometimes used to sample products as they come off assembly line. That's a perfect place in order to check the quality of that manufacturing. So a good example is automobiles come off assembly line. Okay, so here's this little silly drawing. And it says we want to do a systematic sampling of the cars as they come off the assembly line. So we're going to start, so let's see, the starting point will be the third car. So we're going to go ahead and start at this third car. Whoops, something happened there. We're going to start with this third car. So that's the third car comes off the assembly line in the morning. We're going to check that. And then every fifth car after that will be checked. And so this is a systematic sample because we start with the third and then we count 1, 2, 3, 4, 5, and then we do the 8th car, and then 1, 2, 3, 4, 5, and then the 13th car, 1, 2, 3, 4, 5, that's the 18th car. So every 5th car gets sampled, so that's a systematic sampling. Okay. Voluntary response sampling. This is not a very good way to sample, but voluntary response are often used by the media, and it's not, like I said, it's not always representative of the population. And they do this to try to engage the audience. For example, a radio announcer might invite people to call the station to say what they think. Voluntary response samples are never reliable for the following reasons. People who volunteer their opinion tend to have a stronger opinion than the typical population. And you see this on Instagram, on tweeting, and things like that. The people that get involved usually have a stronger opinion than the people that don't. So now you don't have this randomness. And also, people with negative opinions are often more likely to volunteer their responses. Okay, so that is it in terms of the lecture. I need to go back and do the homework problems. But I did say, I don't mean to make this too long. This probably is getting a bit long. But I think I do want to hit that, do the kind of compare contrast with the stratified and cluster, just because those get so so often confused. So let's do a little compare and contrast. Stratified. So stratified, what are some of the characteristics of stratified? Well, the group the population into strata. So group, and they're going to group into strata, which are just groups, by some characteristic. So that's by a characteristic. Because they're grouping by a characteristic, you're going to notice that, oops, that just went too big. You're going to notice that the groups are similar. Or let me say that, groups similar to each other. No, that's not what I want to say. Let's see. If you're going to group by characteristic, this makes the people in each group similar to each other. That's right. So if you're going to make a group by some certain characteristic, let me erase that. That means that people in a group are going to be similar to each other. Similar to each other. At least they're going to be similar to each other by the chosen characteristic that you're trying to do. So like in our example, I believe we said the strata were boys and girls. So the characteristic was gender, and so people in each group had that similarity of gender, right? Okay, so you do that, and then after you do that, you have to randomly select. And so remember, in this example we had the high school that was broken up into boys, and we said there were 300, and then girls. So this, girls. There's no girls, and so the strata was broken up by gender. That was the characteristic that we're breaking this up by, and then after you get your groupings, then you have to perform a simple random sample of each group, also known as strata. And remember, we said, okay, we're going to now take this strata and we're going to do a simple random sample of 30 boys. And then you take the other strata, since there's only two, and you do a simple random sample of 70 girls. Remember, in cluster, our groups, you look at all the groups, you do a simple random sample of the groups, not of the individuals. And then everybody in that group gets taken. That's really the difference right there. That's the big difference, if you could remember that little piece. Let's go to cluster. Cluster, the groups, and this is not a hard, fast rule, but the groups tend to be naturally divided. And what I mean by that is like the example of the Taco Bell survey. Well, the groups were already naturally divided by the stores. They're not grouped by a characteristic. I do want to say that. So they're not grouped by like gender or something like that. And so really the important thing is that the groups are not homogeneous. The groups have variability or diversity, maybe we'll say. So the groups are a mix of people that hopefully are more representative of the population. So in the Taco Bell survey, hopefully when I go to store number 1, if there's a mix of people in there that represents in general kind of like the the mix of the employees across like Northern California, if that's what we're doing this with. And then, but the thing that really drives home the difference with clustering and stratified is that once you have your groups, then, I'm going to write this down, then you randomly select from the groups and then the selected, or let me rewrite that, then all people in the selected groups are surveyed or in our sample. Okay, so hopefully that helps. Let's go ahead and see if that helps us to go back and answer the question. I end up doing a full lecture with this instead of, I usually with this I'm going to just go in and do the homework problems for us. I hope you already looked at some of these notes, but like I said, I know from experience, mainly clustering and stratified are the two that really get us confused. So let's go ahead and start these. So question number 2. Get that out of my way. Question number 2, it says that a researcher asked a simple random sample of 20 so they're doing a simple random sample of 20 homeschooled children. So a simple random sample of 20 children who attended private school. I'm going to draw a picture here. So we've got, and my pen's got to work. There we go. And the pen's still not working. Okay, so we've got homeschooled kids. So we've got homeschooled, we've got private school, and then we have public school. So now you see we already have groups. So the question is this going to be stratified or is this going to be clustering? But here's what really distinguishes this question into the answer, and that is they're going to take, let's highlight this with some red. They're going to take a simple random sample of 20 homeschooled children. So with the homeschooled children, they're going to do it, they're going to look at all the homeschooled children and maybe use a number generator to pull out a sample of 20 of them. So they're not using everybody in that group. If they use everybody in the group, that'd be clustering. But in this case, they're doing a sample of 20 homeschool children. Then let's get another color pen, and they're going to do a sample of 20 children from private school. And then they're going to do a sample of 20 from public school. Okay, so, and let me erase that little mistake right there. Okay, so the fact that they're doing simple random samples with the group, each individual group, and not of all the group as in all, the whole population, this is going to be stratified. Called a stratified sample. All right, next problem. Identify the kind of sample that is described. A sports columnist asks people in a bar about a potential basketball lockout. Talk about a very lazy sample. You go to a bar and start asking people in the bar. Well, this is called a convenience sample, right? We go to a sports column, ask people in a bar about potential basketball lockout. You can see the problems with this sample of convenience, because the people that are sitting in a bar probably don't represent the whole population of like everybody in California or everybody in the United States. So this is not a good sample, but it's called sample of convenience. It's kind of like the example of the teacher who wanted to sample the whole university, and so she just sampled her class. Sample of convenience. It's easy, but it's not very accurate. Question number 4. Identify the kind of sample that's described. 5 placement exam testing locations were selected at random, and all the students at these locations were asked their opinion about the new calculator guidelines. We've got to be careful on this one. I'm going to underline some of this. It says, so 5, if the pencil works, 5 placement exam testing locations were selected at random. Okay, so we're randomly selecting the groups, right? Not the individuals. And I am hearing some grouping going on here. Let me get my pencil going. And so basically what we're saying here is, okay, we got these testing locations. And let's say I'm just going to draw some out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So these testing locations have these numbers. I should have been writing them down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. These testing locations have these numbers, testing location number 1 and so on. And so these are locations. Now, the grouping is sort of naturally done by the testing location. And we'd also say that if we took a look at people at testing location number 1, they're not classified by a certain characteristic. There's all different kind of people that are going to that testing location. So, but those pieces that characterize clustering, those are kind of in general. What really locks us in as being clustering is that 5 placement exam testing locations were selected at random. So that is looking at all the groups, and we're doing a simple random sample of the groups. And they want to, so they put 15 names in a hat, and they pull out, oh, number 13 got pulled. Number 5 got pulled, number 12 got pulled. How many did they say? 5? So I'm 1, 2, 3, 4. And then I pull one more name out of the hat, 7, or number 7 comes out. So then we look at testing location number 3, number 5, number 7, and number 13. But look, it says 5 placement exam testing locations were selected, and all the students of those locations were asked their opinion. We randomly selected the groups, and then once we got those groups, all students or all people in those groups were asked their opinion, okay? So this is definitely going to be cluster. Probably going to have to take a little time with the difference between cluster and stratified, because those, like I said, always get confused. Now we get back to easier methods. A caterer is competing for a company's business. The caterer selects every 3rd item off the menu for testing, making sure, right, that the people on this little assembly line making their food, that the quality stays up to par. So what kind of sampling is described here? Well, these little, I don't know what the guys they're making at the catering place, these little biscuits. Oh man, let's see. Something just happened. There we go. Okay, so let's say the catering company they're making these biscuits. They're kicking these biscuits out. 1, 2, 3, 4, 5, 6. They're just coming out of this little assembly line. and I'll use a different color. It says, Cater is competing for a company's business. The cater selects every third, so 1, 2, and they select that one. 1, 2, 3, 1, 2, 3, 1, 2, 3. Every third off the menu and tastes it. Okay, well, this is something called systematic. Systematic sampling. Okay, a smartphone app produces a message requesting customers to click on a link to rate the app. Now, what does that sound like? Smartphone app producers, they just shoot out a little message that says, click on the link to rate this app. This is going to be called voluntary response because it's definitely not simple random sample. They're not, not everybody, I mean, people had a chance, let's see, everybody had a chance to respond, but a lot of people aren't going to respond, right? So it's voluntary, whereas simple random sample, they randomly select people like a lottery ticket, and they don't ask them if they're going to participate or not. They just grab them, and then they're in that. Okay, but this in particular thing is voluntary response. And we know that voluntary response is not a very good way to get a sample. It can be very, very misleading. Okay, finally, question 7 out of 7. A caterer is choosing menu items for their next year. She assigns each potential menu item a number and uses a random number generator to select 20 items. There's the key right there. Uses a random number generator to select 20 items. Now this is perfect. This is the best, pretty much the best sampling technique, and this is simple random sample, also known as SRS. All right, well, this is Professor Gonzalez signing off, and I hope that this helped out in terms of understanding sampling techniques. Take care. Bye.